Hello everyone. In the previous video we discussed multiplexer. In this video I'll be discussing the next combinational circuit, that is decoders. Decoders are reverse of encoders. So now what is an encoder? In computers, encoding is the process of putting a sequence of characters or sequence of zeros and ones into a specialized format for efficient transmission. And decoding is the opposite process, the conversion of an encoded format back into the original sequence of characters or sequence of zeros and ones. So decoder is a combinational circuit that converts a n-bit binary code into m output lines such that only one output line is activated for each one of the possible combinations of inputs. In other words, we can say that a decoder identifies or recognizes or it detects a particular code. In its general form, a decoder has n input lines to handle n bits and from 1 to 2 to the power of n output lines to indicate the presence of one or more n bit combinations, since each of n inputs can be a 0 or a 1, and therefore there are 2 to the power of n possible input combinations or codes. In simple way, you can say that decoder has n inputs and 2 to the power of n outputs, and in the 2 to the power of n outputs, only one output will be high at a time and all other outputs will remain inactive. So here you can see, for each of these input combinations, only one of the m outputs will be active, that is high, and all other outputs will remain inactive. But in some decoders are designed to produce active low output, and while all other outputs remain high. And nowadays the decoders are available in the form of integrated circuit as a part of a more complex IC. And widely used decoders are often available in the form of standard integrated circuits. This is the general decoder diagram. As you can see here, A0, A1, A2 till AN minus 1, these are the n different inputs, and O0, O1, O2 till OM minus 1, so m different outputs. And these n inputs are represented by using 2 to the power of n input codes, and only one output is high for each input code. That means here decoder has n inputs, 2 to the power of n outputs. Even we can show the enable input for this decoder. So enable is just used to enable the decoder circuit. Either it may be a active high enable or active low enable. Active high enable means whenever the enable pin is high, then only the decoder circuit will be enabled. If active low signal is 0, then the decoder will be enabled. So this is the first type of decoder, that is 2 to 4 line decoder. 2 to 4 line decoder has 2 inputs and 4 outputs. So we know that decoder has n inputs and 2 to the power of n outputs. So here n is 2 and 2 to the power of 2 equal to 4 outputs. And it uses all AND gates, and the outputs are active high, as AND gates give output only when both inputs are high. And it is also referred to as one of 4 decoder because only one of the 4 outputs is activated at one time. And this is the block diagram of 2 to 4 line decoder. Here you can see A and B are the inputs, and D0, D1, D2, D3 are the outputs, and D0 has the lowest priority and D3 has the highest priority. And this is the truth table of 2 to 4 line decoder. So here A and B are the inputs, D0, D1, D2, D3 are the outputs. 2 inputs, 4 outputs. And depending on the input codes, only one output will be high at a time. So now here 2 inputs, there are 4 different input codes, that is 0, 0 to 1, 1. So depending on these inputs, the only one output will be high. So let's consider this two table. A0, B0, D0 is 1, and all other remaining outputs are 0. And for 0, 1, D1 is 1 and other outputs D0, D2 and D3 are 0. And for 1, 0, D2 is 1 and other outputs D0, D1 and D3 are 0. For 1, 1, D3 is 1 and D0, D1, D2 are 0. So that means depending on these inputs, only one particular output is high and remaining all other outputs are low. So the Boolean expression for the 4 outputs are, so here now 4 outputs D0, D1, D2, D3. So we can write the 4 different Boolean expressions. So first for the D0 expression is A bar, B bar, because consider the D0 column here. So D0 is high when both the inputs are 0, 0. So A0, B0. So how do you represent the 0? Just by taking the complement of that variable. So that is A bar, B bar. Hence D0 equal to A bar, B bar. And for D1, so here D1 is high for the input combination 0, 1, and for other combination D1 output is 0. So here A0, B1, so that is A bar, B. So here A bar, B. And for D2, so D2, A1, B0 is A, B bar. And for D3, AB. Okay, so for these 4 different expressions, we have drawn the logic diagram. So here A and B are the inputs, and this is the A bar, the NOT gate output, and this is B bar. Okay, so the first AND gate, for D naught expression is A bar B bar. So here A bar B bar connected to the first AND gate. So D naught equal to A bar B bar. And for D1 A bar B. So here A bar and B, the output D1 equal to A bar B. And for D2 expression is A B bar. So A and B bar. And for D3 A and B. So these are the four outputs. So just by using the AND gate, you can design the decoder. So next, 3 to 8 line decoder. So 3 to 8 line decoder has 3 inputs and 8 outputs. That is 2 to the power of 3 equal to 8 outputs. And again it uses all AND gates, and therefore the outputs are active high. For active low outputs, NAND gates are used. And it is also called a binary to octal decoder because it takes a 3-bit binary input code and activates one of the 8 outputs corresponding to that code. And it is also referred to as 1 of 8 decoder because only one of the 8 outputs is activated at one time. And the Boolean expression for the 8 outputs are, so before discussing this, let's see the truth table of 3 to 8 line decoder. So here x0, x1, x2 are the inputs, and y0, y1, y2, y3, y4, y5, y6, y7, 8 outputs. So 3 inputs means there are 8 possible input combinations. So depending on these input combinations, only one output will be high. So for 0, 0, 0, y0 is high and all other remaining outputs are 0. And for 0, 0, 1, y1 is 1 and other outputs are 0. For 0, 1, 0, y2 is high. So like this, for 1, 1, 1, y7 is high. So remaining outputs are 0. So this is the truth table. So here 8 different outputs. So I have to write the 8 different output expressions. So how do you write the y0 expression? So here y0 is 1. Consider the input combinations. So y0 equal to x0 bar, x1 bar, x2 bar. And for y1, x0 bar, x1 bar, x2. And for y2, x0 bar, x1, x2 bar, and so on. So this is how you can write the Boolean expression for the all the 8 outputs. So same thing I have written it here, and for this only you have to draw the logic diagram by using the AND gates. So this is about the decoders. So this completes the combinational circuits. In the next video we'll start the sequential circuits.